and girls, ladies and gentlemen, welcome to video lesson 12-8, the lesson on the ratios of similar polyhedra. So, as we look at this slide here again, don't forget that we have a ratio. Let me just wait for that clean, there it goes. We have a ratio. How many feet are there in a yard? There are 3 yards. So therefore, as you can see, that the scale factor would be 3 to 1. Which means the ratio of their areas is 9 to 1 because there are 9 square feet in a square yard. And lastly now, the ratio of their volumes is going to be 27 to 1 because there are 27 cubic feet in a cubic yard. So to review, we take the ratio of sides of similar polygons, we take the ratios of their sides and square them, and that's equal to the ratios of their areas. We take the ratio of the sides of similar polyhedrons, and we cube them, and that's going to be equal to the ratio of their volumes. So, looking at this slide right here, we got to decide if these polyhedron are similar. If we look at these two cones, this is cone 1, this is cone 2. The ratio of their radii is 4 to 3, and the ratio of their heights are 14 to 10.5. Those ratios are equal, because 4 to 3 is equal to 14 to 10.5. So therefore, these are similar, and their scale is 4 to 3. If we look at example 2, we have a square pyramid. It's a square-based pyramid, and this is a triangular pyramid. So therefore, those are not similar. Not similar. Looking at this problem right here, we have 2 similar prisms. Their surface areas have a ratio of 98 to 18. If I divide both of those by 2, we have a ratio of 49 to 9. These are the ratios of their surface areas, which is an area measurement. So therefore, we're going to take the square root of both top and bottom, which equals 7 to 3. And that's going to be the ratio of their sides or any other linear measurement. So the answer is 7 to 3 would be the ratio of their heights. This problem right here is very similar. Why don't you guys give the tape a pause and try this one right here. Okay, in this problem, the ratio of their surface areas is 1.6 to 1. If I take the square root of both top and bottom, so take the square root of both top and bottom, the square root of 1.6 is about 1.265. The square root of 1 is 1. So this is the ratio of their sides. Well, that will now equal 66 to x. So x is going to equal 52 centimeters. And that would be the circumference of the smaller ball. Okay, in this problem right here, we have two similar cylinders, and their radii are 15 and 6. So therefore, the ratio of their radii is 15 to 6, which can be reduced to 5 to 2. Well, that's the ratio of their lengths. So therefore, let's find the ratio of their areas. We're going to square. We're going to square both 5 and 2. That equals 25 to 4, and that is the ratio of their areas, their surface areas. You guys try this one. It's very similar. Give it a go. Okay, the ratio of the diameters of these two spheres is 15 to 11. That's the ratio of their linear measurements. So what we're going to do with this is we're going to say, okay, if one of them is 15 and the other one is 11, that's the ratio. X to 55 would be the ratio of their diameters. So x is going to be 75. If x is 75, that's the diameter of the larger ball. So therefore, the radius is 37.5, half of that. So now we're just going to use our volume formula to find the volume of that larger ball. So our volume is 4/3 pi r cubed, which equals 4/3 times pi times 37.5 cubed. Whip out your little mini calcs, and we're going to get a total answer of, when we're all said and done, 220822.75. Voila.